Hey guys. So today we're going to cover another topic that comes up quite often, and I see a lot of responses being provided on Facebook groups that are frankly quite inaccurate. And the question is, does an RCA cable get affected by electrical noise, EMI, whether it's a cheap $5 Amazon cable or an expensive $40 well-known brand cable? So today we're going to see whether or not these cables are indeed impacted or influenced by AC or DC signals, right? Electromagnetic interference. And if so, we're going to see how much. This way, we could have an analyzer provide us the data rather than relying on folks saying yay or nay based on marketing materials. So let's begin and let's talk about the test setup that we have here and exactly what I'm going to be showing everybody. So we have our Quantasylum QA403, and it's connected to a laptop. So it's being powered by USB and nothing is plugged into the wall. Fully running off of battery power. That way we have no ground loops or anything else happening. We have the RCA cable simply going from the output of the left channel into the input of the right, of the left, and then right input of the right. We have a cheap $5 Amazon cable. We have an expensive $40 Stetson triple shielded RCA cable, right? This is what the marketing is all about. These things are wonderful and they'll save you. So what we're going to be doing is running fast Fourier transform at 64K and 96 kilohertz sampling. So that's a lot of data that we're capturing. And then we're going to be averaging that by 6. So we're going to take 6 samples, average them, and then see exactly the type of noise that we're looking at. So right now, everything is quiet, and we could see we have about negative 115 or so dB across the board, across all frequencies, a little bit of a spike. And if you're wondering why, right, so that kind of already gives you an idea of whether or not RCA cables are susceptible to noise. Now remember, I've talked about this before. RCA cables are not like the balanced cables where you have multiple conductors. You have a center ground and positive and negative. RCA, you basically have a ground that's shared, and then you have the other conductor that's very susceptible to noise. So what we're going to do for this test is we're not going to generate a signal or anything. We're literally going to listen to the noise on the RCA cable, and we're going to generate that noise by having this iPad run a frequency generator via Bluetooth into that cheap stereo that is feeding into that jail audio amplifier, which is then putting out a signal into this resistor bank. The idea here is we're going to mimic a speaker playing music. So this is an AC signal, and I have my probe hooked up so you can actually see the amount of power we're going to be passing through when everything is on. So let's get started. Let's set our frequency generator to 500 hertz. It's turning on. We're going to see there's the amplitude, 12.4 volts out into the resistors. And look at that. 500 hertz is being picked up by these RCAs, even though physically these wires are quite far. Now what happens if I take my cheap and expensive triple shielded RCA and I overlap them with this AC signal? Look at that spike. Now remember, because we are averaging the data, it's going to take a little while for all of the samples to settle. But can you believe that? We have basically a noise floor of negative 115, and now we have about negative 70 dB worth of noise at 500 hertz. So what this tells us is if these RCAs were actually pushing data that was being amplified by the amplifier, we'd have all of this piggybacking on the RCA. Now, to show that this is indeed a real-time test, right, I'm going to leave those there. Now I'm going to, let's change it to 125 hertz. And let's capture that. 500 should slowly go down, and now we should have 125 slowly creep up. Now, what happens if I take the volume on the radio and I turn it down? That way we're putting out less AC signal, right? So this is a low-powered speaker or low-powered subwoofer. Noise goes down. And if I turn to the right, what happens if we do the opposite? Right, so there it is. I'm increasing the volume on the radio. And what you'll see is the noise will go up. Let's once again try 1 kilohertz. See what happens there. It's a higher frequency, so it's getting even more noise. Now we could see all this additional noise being caught as well, because now our circuit has some ringing in it. 2 kilohertz. Oh yeah, look at that. And once again, if I take these wires and I move them physically away from that, right, create some isolation. Let's see what happens. Does it go away? Yep, it starts settling because now the physical proximity, right, even though we're talking about 6 inches or so, made a huge difference. So let's take our super expensive $40 triple shielded RCA. And once again, that's the red, the right channel. So we could see it's picking up the noise, right? Let's put it down and let's take our cheap $5 RCA. There's the yellow. So it's picking up more noise, right? We could see that yellow had more noise than the red, but it didn't really save us. Even though it was triple shielded, the noise is still there. So if going from $5 to $40 is worth it, I mean, you're definitely getting some noise canceling. Is it significant? It's really up to you. But what I'm trying to show in this video is to answer the question with this very simple test that yes, your RCA cables crossing electromagnetic paths, especially your lines going to your subwoofer or speaker, will introduce noise. If you appreciate this test and this information you'd like to see more, please let me know in the comments and by liking. I love to do these types of videos as long as I know that it helps somebody, right? I want to know that my time is worth it and people are finding value in this and they could go back to their build and clean it up by taking the appropriate steps based on what they see here.